So good day guys, today we're gonna work on this worksheet number 5 about finding the critical numbers and intervals of increasing and decreasing of the following functions. So before we do that, let's review a bit about the critical numbers. Right? What is critical numbers? We know that critical numbers are those numbers inside the domain of a function which either makes the derivative equal to 0 or makes the derivative not to exist. So what I'm saying here is critical numbers, firstly, must be in the domain. This is the very first assumption that we must have. And apart from that, there is two types of critical numbers. The first type is those makes the derivative equal to 0. And the second type is when the derivative does not exist. Okay, so after knowing this, we can get started now. Work on the first one. The first function here is a polynomial function, right? So its domain is going to be all the real numbers. And then we can take the derivative, which is 3x squared minus 27. And we can do a little bit factorization to simplify the derivative. So it's 3 is minus 9, right? Which is 3x plus 3x minus 3. Right? Okay, so now let's try out these two types of derivative. So firstly, we know that this derivative is also a polynomial, right? Which always exists because the domain of a polynomial is all the real numbers, right? Always exists means that the derivative won't does not exist. So this thing tells us that there's no critical number of the second type because it always exists. Okay, so there's no such a type of critical numbers. Now we are left with the first type of critical numbers, which is when the derivative equal to 0. So now let the derivative equal to 0, right? And now we have 3 times this equal to 0, which tells us that x minus 3, x plus 3 is equal to 0. And because the product is equal to 0, so either the factors is equal to 0, either factors. So x equal to negative 3 or x equal to 3. Right? So these are the critical numbers of the first type. Okay, and because there's no critical numbers of the second type, these are all the critical numbers. So now we have CR here, negative 3 and 3. So that is how we find the critical numbers. Now we also need to find the increasing and decreasing intervals. So we draw the number line here and then place all the critical numbers on this number line, right? Negative 3 and 3. And you're gonna plug in the derivative at a chosen point in these 3 intervals separated by the critical numbers here. So for example, plug in negative 4, right? This is less than 0. Greater than 0. Plug in this f prime 0, right? That is less than 0. Plug in this, for example, 4 here is greater than 0, right? So now we have positive here, right? Negative here and positive here. So the function is increasing, decreasing, and increasing. So it's increasing on negative infinity to negative 3, from 3 to positive infinity. Decreasing on this interval from negative 3 to positive 3. Okay, so that is how we handle this question. Increasing and decreasing intervals. So now let's move on to the second question. So this is a rational function, right? Its domain is everything but negative 2. Because when y is equal to negative 2, the denominator is going to be 0, which is not allowed. And except for that, every number is a valid input. Okay, so that's the domain. Okay, now we're going to find its derivative by using the chain rule here. So that is 6 times y plus 2 to the negative 1 derivative, right? Which is 6 times negative 1 times y plus 2 to the negative 2, which can be written as negative 6 divided by y plus 2 squared. Okay, so this is the derivative function. And now we know that this derivative does not exist, right? This thing. And y, when y is equal to negative 2. Okay, so by our previous discussion, right, it's very tempting to say that y equal to negative 2 is the second type of derivative, right? But we should know that at the very beginning we emphasize that critical numbers must be in the domain, right? So we've known that negative 2 is not inside the domain. So even though the derivative does not exist at this point, it's not our critical number of the second type, right? So but this is not, but it's not a critical number of our second type because it's not in the domain, right? Because it's not in the domain. In the domain D. Okay, so that means there's no CR of the second type, right? Because that is the only point that the derivative does not exist, and that is not a critical number, so no critical numbers of the second type. Now later on we're gonna take a look at the derivative of this first type. Can the derivative be equal to 0? That is also not possible because this derivative is a fraction, right? It's a fraction here. And for a fraction to be 0, we need a numerator to be 0. But the numerator here is a constant which can never be 0, and the denominator cannot be 0, right? So There's no chance for this to be 0, so it's never 0, right? Which means that no critical number of the first type, right? No critical number of the second type, no critical numbers of the first type. So overall, there's no critical numbers. Okay, no critical numbers. So no critical numbers, but we still need to draw the number line to find out the increasing, decreasing intervals. There's no points to place on the number line here, except for this -2, which is not in the domain, right? And now we're gonna find out the sign of the derivative on these two intervals separated by this number, right? You see that the derivative here has the square inside a denominator. So the denominator is always greater than 0, has the plus sign, but the numerator is negative, so this derivative is always less than 0. Always less than 0. Negative sign here, negative sign here, which means it's decreasing here and decreasing here, right? So it's decreasing on this negative infinity to -2 and -2 to positive infinity. Okay, if you draw the diagram, it looks like that. This is the y, the -2 here, right? And it goes like that, right? Decreasing here, decreasing there. So that is the kind of the graph of this function. It's like the reciprocal function. Okay, so that is our question B. There's no critical numbers, but it's always decreasing. And now let's move on to the next one, question C. As before, this is a polynomial function, so the domains are the real numbers. And now we take the derivative, so we have -27 z to the 2 minus 18z plus 72, and now factor out this maybe 9, -9, so we have, oh, this is not 27, it's just 9, okay. So that is -9 z squared plus 2z minus 8, which can be further factored as z minus 2 z plus 4. Right? And because this is a polynomial function, right, this derivative always exists. And as before, this implies that there's no critical number of the second type. Okay, so we can only look for critical numbers of the first type. So we'll let this hz equal to 0, the derivative. And now we have this equal to 0, which implies z minus 2, z plus 4 equals 0, and it's either z equal to 2 or z equal to -4, right? So these are the critical numbers of the first type. And because there's no critical numbers of the second type, these are the only critical numbers, okay? And now we draw our number line. Let's CR here. -4 and 2. And then we're gonna test out the derivative. Maybe test out the this, right? This is less than 0. Plug in this here. Plug in this, right? That's greater than 0. Maybe this less than 0. So it's gonna be negative here, positive here, and negative here. And now it's decreasing, increasing, and decreasing. So the function is decreasing on this negative 4 and from 2 to positive infinity, but increasing on this. Okay, very similar to the first question, question A. If you understand question A, you should understand this. Question C. It's no critical number of the second type, only critical numbers of the first type. So that is this. Now moving on to the next one. Here. So this is a difficult question. It's a product function, right? So we gonna use the product rule to figure out its derivative. But first, let's denote that this derivative, this domain is all the real numbers. Okay. And then we take the derivative with respect to Q by using the product rule. So derivative of this, right, times this plus this times the derivative of that. So now we have 1 here times EQ plus times the derivative of EQ, which is EQ itself. And then simplify this a little bit just to factor out this EQ, right? And we're left with 1 plus Q plus 3, which is EQ, Q plus 4. Okay, so that's product, right? So this function is the polynomial function times the exponential function, which always exists. So it means that there's no critical numbers of the second type, right? Because always exist. So we can only look for critical numbers of the first type. Now let this derivative be equal to 0. We have EQ times Q plus 4 equal to 0, right? We know that this product equal to 0 is equivalent to either of the factors equal to 0. So it's either this EQ equal to 0 or this bracket Q plus 4 equal to 0. But since the exponential function can never be 0, right? Because it's always greater than 0. Right? Because of that, we have to have Q plus 4 equal to 0. That is the only choice for the derivative to, only possibility for the derivative to be equal to 0, right? So this implies that Q is equal to negative 4, right? So that is critical number, right, of the first type. So that is the only critical numbers we have here, because there's no those of the second type. Now after this, we kind of graph the number line and place our negative number here, place our critical number here, negative 4, right? And then we're gonna test derivative, maybe p of negative 5, right? Derivative that is less than 0, p of maybe negative 3, right? You plug in, right? See this expression here, that is positive, right? So it's going to be decreasing here, increasing here, because negative sign here, positive sign here. Now we draw our conclusion. This is decreasing on from this to -4, and increasing on from this to positive infinity. So that is our question D. You see that the difficulty here is to find the derivative by using the product rule and also do the factorization. And also notice here, a product equal to 0 implies that either of them is equal to 0. But the exponential function cannot be 0. So it forces the other one, the other factor, q plus 4 to be equal to 0. And that is our only critical number, because there is no critical numbers of the second type. Okay? It should be very similar to the previous questions, except for the product rule we use and the exponential function we've seen here. So let's move on, continue to question E. This function, right? So this function is like that. T squared minus 4, right? Square root of 3 is like that, right? So it's taking the cube root, not the square root, right? So the sign of the thing underneath the cube root does not matter, right? It does not have to be greater than or equal to 0. And because of that, its domain is all the real numbers. Every number you plug in is always valid. Okay? Domain is all the real numbers. Now, after knowing that, we find the derivative by using the train rule. Right? So that is 3 over 2 goes down here, right? And this becomes 2 over 3 minus 1. So it's negative 1 over 3. It's the previous power, subtract 1. Right? And also we need to times the derivative of the second layer, the inside function here. That is, this guy here. Right? So that is 2t. Right? And this is simplified to t squared minus 4 times this negative 1 over 3 here. And 2 goes to the front times that 2, so it becomes 4 here, right? There's 1 times t. So it's like that, right? And still, this expression here does not have any square root, right? Only has the cube root, right? Cube root does not matter, right? So this one always exists, right? But we should take a look at this negative power here. So let's simplify it. Negative power means this t is here, right? This cube root is in the denominator. So when it is in the denominator, we should pay attention to it, right? Because denominator cannot be 0, right? So we know that this thing always exists, except when t squared minus 4 is equal to 0, right? So it does not exist here when t squared minus 4 is equal to 0. because that is in the denominator. Denominator is not allowed to be 0, right? So that is when t is equal to positive 2 or negative 2, if we solve this, right? So we know that this thing is the critical number of the second type, right? When the derivative does not exist. Okay? And because we know that the domain is all the real numbers, right? It's inside our domain. So it's the second type of critical numbers. And after knowing that, let's take a look at the derivative being 0 to figure out the first type of the critical numbers. So now let this r of t prime equals 0. We have this thing equals 0, right? So the only possibility is when the numerator equals 0, right? So we have t equals 0, right? So that is the critical number of the first type. Okay, derivative being 0. Just notice that denominator cannot be 0. So we have had the critical numbers of the first type and the second type. So all the critical numbers here are negative 2, 0, and positive 2. Okay. And after having these numbers, draw our number line and place them here, negative 2, 0, and positive 2, and then find out the sign. Right? For example, you can plug in like a negative 3, right? You plug in negative 3, and then it's going to be less than 0, right? So it's decreasing here. If you plug in like a negative 1, it's going to be positive. Right? So it's increasing here. And if you plug in like positive 1, then it's going to be less than 0, right? So it's here. And plug in 3, that is going to be positive, right? So it's increasing here. Right? If you're not sure about that, just use a calculator to plug in. You can figure this out very, very soon. I just look at these expressions here, right? This expression and that expression. That are the only expressions determining the sign. So I know that when t is negative 3, the top is negative, and the bottom is also negative, positive, right? So that gives us a negative sign. Okay, just something like that. So after having these things now, we can say that the increasing intervals are this from 0 to 0 and 2 to positive infinity, and the decreasing intervals are from negative infinity to negative 2 and from 0 to 2. So it's a little bit more complicated than the previous questions, but it's nothing more than doing the derivative, figuring out the first type and the second type of critical numbers. And it's a little bit tricky to determine the sign, but you have a calculator, you can just plug in to do the computation. Okay, so that is our question E. Now moving on to question F. Here. is a power function plus a reciprocal function. So its domain is everything but 0, right? Because it's in the denominator. And after knowing this, we can start to take the derivative. That's 1 minus 4d squared. Right? So this is a reciprocal function, right? We know that it does not exist when d is equal to 0. Right? But 0 is not in our domain, right? So even though it's very tempting to say that this is a second type of critical numbers, but it's not, right? Because of that, no critical number of the second type, because it's not in the domain. So we can only look for the critical numbers of the first type. So now let this equal to 0, and we have now 1 minus equal to 0, right? So 1 equal to this, right? And it implies that d squared is equal to 4. So d is equal to positive and negative 2, right? So these are the critical numbers of the first type, right? And they are the only critical numbers. So after knowing this, we can now draw our number line and place this negative 2 and positive 2 here. And also the number that is not in our domain, that is 0 here. That separates the number line into several intervals. And now we kind of plug in numbers for this expression, right? So for example, plug in like negative 3, right? And you see that this is going to be negative 3 squared, that is 9, right? 4 divided by 9 is 9 over 4 over 9, and 1 minus that is positive here, right? It's increasing, right? And also positive here, not positive there. So if it's greater than negative 2, that is going to be, for example, 1, right? 4 divided by negative 1 squared, that's 1, that's negative, right? So it's decreasing. You can see that's also decreasing here, right? Negative. And at there, 1 minus that is positive. 1 minus, for example, 3, right? Same as the negative 3. So increasing here. Okay? So after figuring out this information, we know that the increasing intervals are from this to negative 2 and from 2 to positive infinity. And they're decreasing on from negative 2 to 0 and from 0 to positive 2. Okay, so that is this question, right? Exact same format, finding out the domain and then figuring out the second type of the critical numbers and first type of critical numbers. Write them all on the number line and figuring out the increasing, decreasing intervals. Okay, should not be too difficult to understand. Now we want to move on to the next two questions. This one. Okay, so it's a log function, right? We know log function requires that the thing here is greater than or equal to 0. But since it's a square plus 1, square is always greater than 0. Plus 1 is always greater than 1, right? So let alone 0. So this one is naturally always greater than or equal to 0. So it means that the domain, it's all the real numbers. Because L squared plus 1 is always greater than 0. There's nothing to worry about. And now we find the derivative K prime L. That is by the chain rule, right? So it's 1 over this L2 plus 1 times ln 7, 1 over ln 7, okay, and times the 2L, which comes from the inside function. The inside function is this one, right? That is the derivative of L squared plus 1, that's 2L here, by the chain rule. Now we kind of simplify this, right? This is 1 over the ln 7 times, actually I can place the 2 here, 2 over ln 7 times L divided by L squared plus 1. Okay. Now we can say that this thing always exists because the denominator cannot be 0, is L squared plus 1, right? So it's always exists. Means that no critical numbers of the second type, because always exist. So we can only look for the critical numbers of the first type. And first type, that is, let this K prime L equal to 0, right? So we have 2 divided by this times L squared plus 1 equal to 0. And we know that for a fraction to be 0, is the numerator being 0. So L is 0 in this case. Okay, so this is the critical number of the first type. And it's our only critical numbers because there's no others of the second type. So now, after knowing what our critical number is, draw the number line, place this number here, only number. Okay, and now we're gonna take a look at the sign of the derivative on these two intervals. For example, when L is equal to -1, this is negative, right? So decreasing here and increasing here. So it's decreasing on this to 0 and increasing on this from 0 to positive infinity. Very simple, except the chain rule here, right? So that is our question G. That should be obvious. Now the last one has this one here. Firstly, figure out the domain. We have that the denominator is n minus 2, so we know that the domain is all the real numbers except this one, 2. It can be 2. When it's 2, the denominator is going to be 0. So excluding that number, now we have the domain and we can find the derivative. Okay, For the derivative, I am gonna, I can use the chain rule, but that is not efficient in this case. So I'm gonna simplify this a little bit first before we find the derivative. I'm gonna create something here. This is -4 and +4. So I'm gonna do that on the top, right? So that I can split this into two things, and square -4 divided by this, and +4 divided by that. Okay. Notice that here, -4 and +4 does nothing, right? So this is equal to the previous expression. The reason I am doing that is because I want to create the perfect square, the difference of square formula, make use of the formula here. So that now I can change my first term into n minus 2 n plus 2, right? Divided by n minus 2. And the second term is this one. So now I can cancel out this just to make things easier. And so I'm left with n plus 2 plus 4 divided by n minus 2. So now when we take the derivative, it's easier right now. So the derivative now becomes 1, right, minus 4 and minus 2 squared by the power rule. Okay, so that is our derivative, right? We know this derivative does not exist when n is equal to 2, right? But 2 is not in our domain, right? So this implies that no critical number of the second type, right? 2 is not in our domain, even though it makes the derivative not exist. So we can only look for the derivative of the first type, right? The first type is when the derivative equal to 0. Equal to 0, right? Now we have the 1 minus this thing equal to 0, which implies that 1 is equal to 4 n minus 2 squared, right? And tells us that n minus 2 squared is equal to 4, right? So now we have n minus 2 equal to positive or negative 2. And now we add 2 on both sides. So we have n equal to plus minus 2 plus 2, right? Which means that n is equal to 4 or 0. Okay. So these are the critical numbers of the first type. Okay, when the derivative is equal to 0. Okay, so after having these derivatives, these critical numbers, we draw the number line and place all the critical numbers on the number line. That is 0, right, here, and 4 here. But don't forget this guy here, n equal to 2, right? That's when the derivative does not exist. So 2 is also here. And now we're going to figure out the sign of this derivative on each of the intervals created below. Okay, so for example, we can plug in maybe number -1, right? Plug in -1, you have -3 squared, that is 9, right? So that is a fraction smaller than 1, so we have positive sign here, positive sign here. So it's increasing here, right? And on the other end, we also have positive sign, right? And negative sign on these two intervals. Okay. And now, after knowing this, we can say that the increasing interval, so negative here of infinity to 0 and 4 to infinity, and decreasing on the 0 to 2 and 2 to 4. Okay, so that is how we figure this out. The last question actually is similar to which question? The question H, right? Do you see the derivative here? Is similar to the question F, right? So these questions are similar, and these questions are similar, right? And yeah, that's it. And this question is kind of a little bit tricky, right? A little bit special, right? And but this question is similar to this one. Okay, so that is our problem 1 about finding the critical numbers and increasing and decreasing intervals. You see that the steps are always like figuring out the domain first and find out the derivative, and then analyze when the derivative does not exist and equal to 0, right? So figure out the first type of critical numbers as well as the second type, and then we draw all of them on the number line to figure out the sign on each of the intervals separated by those critical numbers. And that should be very intuitive. So I think that's all for today. Any questions? Any other questions?